Hey everyone! Today we're going to go through finding the volume of pyramids and cones. So I hope you're finding that volume is a little bit easier than surface area. It definitely is. The only main hard part with finding the volume of pyramids is just like prisms. The base of that pyramid can be any shape, and so you need to remember all of your formulas for area. The volume of any pyramid with any base is equal to 1/3 the volume of a prism with the same base and height. So see here, we're filling up the sandbox. So it would take exactly 3 pyramids of the same base to fill up a prism. Formula people, here for you. Volume of a pyramid, volume equals 1/3, big B times H. Big B stands for area of the base. Doesn't matter if it's pushed over or not, it's still going to be the same. Right, 12.5 examples. Again, we're going to use our formula for the volume of a pyramid. So the volume of a pyramid equals 1/3 area of the base times the height. In this case, our base is a square, so it's 10 by 10. So the area of the base is 10 by 10, 100. So volume equals 1/3 area of the base, 100, times the height, which is 12. Put that in your calculator, or we can just do 1/3 of 12 is 4, and 4 times 100 is 400. 400 centimeters cubed. Honors example problem. This one's definitely quite a bit trickier, so everyone's welcome to try it. This is one that would only be tested by honors though. So again, volume equals 1/3 area of the base times the height. Area of our base this time is a hexagon. So we need to remember that the area of a hexagon is the formula area equals 1/2 apothem times perimeter. Each side is 12, so our perimeter would be 12 times 6. But we don't know our apothem, so remember how we have to find that apothem? So we need to actually drop down a right angle here and make a triangle. And then we need to find this angle right here. So I'm going to take this triangle. That's what we're going to work with. That's our apothem. We don't know it. We actually know this side would be 6 because it's half of that 12. 360 degrees is a whole circle. So this distance all the way around here would be 360. There are 6 exact pizza slices. So 360 divided by 6. 60 degrees would be this whole angle right here. Cut that in half. So we get a 30 right here. Okay. We're going to have to use tangent, opposite of our adjacent. So tangent of our angle 30 degrees is equal to the opposite side, which is 6, over our adjacent side, which is A. Let's solve this for A. Multiply both sides by A. So A would end up equaling 6 divided by the tangent of 30. I'm going to go ahead and plug that into our calculator. 6 divided by tan 30. At least deep breathing, I get it, Wrigley. 10.39. So A is 10.39. Okay, we're going to take that, plug it in here. Area equals 1/2 our apothem, 10.39, times our perimeter, 12 times 6. Brain doesn't do mental math right now. 12 times 6, 72. Plug this all into our calculator. So our area is going to end up equaling 1/2, 10.39 times 72. 1/2, 10.39 times 72. 374.04. That's just the area of the base. Fun, right? We're not quite done. So that's our area of base. I'm going to switch colors so we can see what we're working with now. So the area of the base, 374.04. Formula is 1/3 area of the base times height. So now our volume is actually going to be 1/3 area of the base, which we just found 374.04 times our height, which is 20. So I'm going to plug all that into our calculator and get our final answer. So I'm going to actually take that amount. So 1/3 times that 374.04, and then we're going to times that by our height, which I already forgot, 20. I think I checked. And 2493.6. And that would be centimeters cubed. That's our final answer. Again, that one's honors. Give it a go. See how you can do. And let me know if you have any questions. Cool fact, consider a cone with a regular polygon inscribed in the base. So you have that polygon. In this case, there is a pentagon inscribed in the base. As you increase the number of sides of that polygon, it approaches the base of the cone and the pyramid approaches a cone. So the more sides, the closer it is to becoming a cone. All right, volume of a cone formula, just like volume of a pyramid, except for your base is a circle. So we're going to plug in the formula for the area of a circle for the area of the base. Volume equals 1/3 pi r squared times the height. All right, 2 more examples here. These ones are the volume of cones. Find the volume of this cone. Again, I like to start out with the formula. So volume of a cone equals 1/3 area of the base, which is pi r squared in this case, times the height. So let's plug in what we know. Volume equals 1/3 pi. The radius is 5, and the height is 8. Actually, wait a second, you guys. The height's not 8, is it? The slant height's 8. We don't know the height. How do we find the height? Oh, Wrigley should have reminded us to use the Pythagorean theorem. We need to find that height here. So we do have a right triangle. The hypotenuse is 8. So you're going to use the Pythagorean theorem. A squared plus b squared equals c squared. A and b can be h and 5. H squared, the c just has to be 8. So h squared plus 25 squared equals 64 squared. Sorry, not squared. Let's undo that really fast. Undo. H squared plus 25 equals 64. So h squared would equal, we would subtract 25 from both sides. So 64 minus 25. 39. So h squared equals 39. In order to find h, we need to square root both sides. So we're going to find the square root of 39, and that's going to actually give us our height. 6.24 rounded, 6.24. We'll just keep it at 6.24. So that is what we're going to actually plug in for our height, 6.24. Plug that in, so times 6.24. Then we can have the volume, 1/3 pi times 5 squared times 6.24. Again, this is why Desmos is so great. 1/3, you can just type it all in at once. If we remember, 1/3 pi times, what was the radius? 5 squared times 6.2. You can even put more numbers in here to get more accurate. 997 998. But our answer 163.49. And these would be meters cubed because volume cubic units. Last problem for this lesson, the volume of a cone is 351 pi cubic yards and the height is 13 yards. Find the radius. Let's write our formula. Always the first thing you want to do. 1/3 pi r squared h. Let's plug in what we know. We know the volume is 531 pi. Don't miss that pi. Sorry, 351 pi. That's going to equal 1/3 pi times the radius squared, which we don't know, it's what we're trying to find, times the height. Height is 13. Okay, we can do a bunch of things here, some algebra tricks. My first trick is, since we have pi on both sides of the equation, I'm actually just going to cancel out the pi's, so those go away. And then I don't like fractions because I think they make the problem a little bit harder for you to see like what's going on. So right now it's 1/3. In order to get rid of that, we could just multiply both sides by 3. So multiply this side by 3, we multiply this side by 3. So 3 times 351. What, 1053? So we got 1053 here. Equals, what do we have left? R squared times 13. Okay, we want to divide both sides by that 13 to get rid of it. So 1053 divided by 13. $81. Oh, this is a nice problem. It's gonna work out perfectly. Crazy. So our kind of ran out of room here, but we have is 81 equals r squared. Well, in order to solve for that r, we need to square root both sides. What's the square root of 81? 9 times 9 is 81, so the answer is 9. 9 is our radius, so our radius is 9 yards. One-dimensional. Okay.